Alright everyone, welcome to day 17 of Advent to Code. Yesterday's was hard to say the least. I still don't have both stars, you can see. I only have star for part 1. Working on getting star for part 2. I still just cannot totally figure out the best way to go about solving it, but at any rate, 15 was rough, 16 was even more rough. Here's hoping that day 17 today isn't quite as bad, and that hopefully we can at least get it done. But at any rate, 5 more seconds here for day 17. Everything's set up. Let's go ahead and get this one done. Your handheld device is located an alternative exit from the cave for you and the elephants. The ground is rumbling almost continuously now, but the strange waves valves buy you some time. It's definitely getting warmer in here, though. The tunnel is eventually open to a very tall, narrow chamber. Large, oddly shaped rock are falling into the chamber from above, presumably due to all the rumbling. You can't work out whether rocks will fall next, you might get crushed. The 5 types of rocks have the following particular shapes. It's like Tetris. The rocks fall in the order shown above. First that shape, then this shape, and then so on. The last region, then it repeats. The rocks don't spin, but they do get pushed around by jets. This is Tetris. A quick scan reveals the effects of the jet case. For example, suppose a jet press that. In jet patterns means a push to the left, while it means a push to the right. The pattern above means the jets will push the falling rock right, then right, then right, then left, and okay, yeah. So on. Tall vertical chamber is exactly 7 units wide. Each rock appears so that its left edge is 2 units away from the left wall, and its bottom edge is 3 units above the highest rock. And its bottom edge is 3 units above the highest rock. Okay. After a rock appears, it alternates between being pushed by a jet of hot gas, 1 unit, and the direction indicated by the next symbol in the jet's pattern, and then falling 1 unit down. If any movement would cause any part of the rock to move into the walls, floor, or a stopped rock, the movement instead does not occur. If a downward movement would have caused the falling rock to move into the floor or an already fallen rock, the falling rock stops where it is, having landed on something in your rock. It is Tetris. Okay. With and stop rocks with then jet pattern above. Okay. Yeah. Falls one unit, jet that pushes it, rock heights. It repeats. So okay, so it doesn't start. So we have 2. Okay, I got it. Movement begins. So we get Tetris. Hey. To prove the elephants are simulation accurate, they want to know how tall the tower will get after 2,022 rocks have stopped, but before the begins falling. How many units tall is the tower? Okay, welcome to the wonderful world of Tetris. So this isn't too bad. So it says it's it starts it says 3 units above the vertical chamber is 7 units wide. Each rock appears that its left edge is 2 units away from the left wall, and its bottom edge is 3 units above the highest rock or floor. So it's technically 4. Technically 4. Oh wait, 0, 1, 2, 3. Okay, so because that's technically 0. 4. Okay. So, basically we need to code up our pieces. So we're going to need a list of points, but it's gonna be I don't want to make this a map. Let's just make it a list of points. private static final, and then I'm gonna go ahead and do this static bit. That way these are pre-generated. So we're gonna do pieces, add. You know what? Yeah, let's do it this way. Okay, so what are our pieces here? So we have a dash. We're always going off of the left side. So, so this one. So it's the left edge, right? Volume it down. Where does it say? Left edge, yeah. Okay, so it's going to be point. We're going to do, it says row column, but fine. I'll keep these as row column. Okay, 2 and 3. Okay, and then we have plus up next. So 0, 0. Okay, that's fine. And then we're gonna get 1, 1, 1, and -1, 1. Okay. I guess technically I can do this, can't I? Technically. Okay, and then what's after the plus is this weird L shape, so that's fine. And then it's gonna go up 1 to 2, then 2 to 2. And then we have this line, which I'll steal the dash for, but 1, 2, 3. 1, 2, 3, 4. No, 0, 1, 2, 3. That's all we need. Okay, so we have dash plus reverse L. Call a stack, and this is a box. 0, 0, 1, 0, 0, 1, 0. 0, 1, 1, 1. Sure. Okay, so those are all the pieces that are in the order that they want them to be. And our input is one long line. So we're gonna need int index equals 0. And now we get to do this. For int I equals 0 while I is less. Wait, it wants that many pieces. Fine. 2022 I plus plus. So this is our loop that's control how many the rocks are falling. So when a rock falls, set is false while not set. This is what's going to control our little loop here. That not loop. This is control the movement down. So we have a piece index. And we have a What are these things called? This jet index. Okay, and so we do piece index plus plus, list of points. This is piece point is pieces get piece index. Cool. So now we have our piece. So what we need to do is we also need a hash. Let's just do a list of points here, and these are going to be our set points. Make life easier. Okay, so while it's not set, what we're going to do is first check the position we are at. Well, if it's only supposed to be, so no, we can always move it first. So what we can do is char, this is going to be jet char is going to equal input, let's do string. This is the jet pattern. So this is gonna be jet pattern char at jet index plus plus. So if the jet char, we're gonna need an offset, aren't we? Point offset equals new point 0 0. That's fine. Jet char equals this way. Otherwise this. So we go ahead and we do offset equals new offset. So it gets pushed first and then falls. So it pushes and then falls, but if it falls and hits something below. Okay, I got it. Equals new point. So we do offset dot row minus minus or minus 1, and then offset dot actually it's me math dot left, so it's me math dot max of 0 and offset dot column minus 1. Otherwise here, same thing, but we increase column and we do a min of, it says 7 units Y, which means a 6. Okay, so now we have our new offsets, and all we gotta do is check Boolean hit equals false for point P in piece, point offset or P offset equals new point, and this is going to be P dot row plus offset dot row and then P dot column. Oh, it's int width equals piece. I'm gonna call a stream here. A B A dot column minus B dot column. No, B minus A. We want to find the maximum. Get column. Okay, so now we have our width. So it's gonna be 6 minus width. Because if the width is 1, yeah. Because if the width is 1, it can occupy that 6th spot. That's why I have to go 7. Yeah. Okay. So that'll make it so it can't go off. And because the left side is always 0, that doesn't matter about that. Oh, but okay, so we also need to start it. We also need to start it at a certain height, don't we? So where offset comes in. So this is where we start offset of 2. And then how do I start it at the height? So I'm gonna say we need the height. I don't wanna. Is this gonna work? Hold on. I don't know if this is gonna work. Width is 0. Okay, so this is gonna be A, B, A, B, which simplifies this code down. I guess I'm gonna simplify it, but so in theory we should see 0 on the height and 3 on the width. Oh, this needs to stay at 6 though, because the width is 3, but it's actually, yeah, okay. Height 0, that's fine. So we have the width and the height. The issue comes. I feel like this is wrong. I should make a piece class, because this is gonna hurt me if I, yeah, static class piece. This is gonna be points, public. We need a public int width. Might as well, because there's no point to I mean, we could recalculate every time if I wanted to, but there's a better way to do it though. With ylow. Generate. Generate. Oh my god. Generate. Constructor. This. Okay. With 3. I guess we do width of 4. And 0. And that goes there. Okay. And so take this up. This is going to be 3, -1. 3, 0. 4, 0. Oh, no. 0, 0, 1, 0. And 2, 0. Okay. Int with actually we can just do piece. So piece dot with, so now we gotta bring it back to 7. Okay, and then the row is gonna be, we need the height. So highest plus piece dot ylow. Okay, now that offset's been correctly done, so now piece p. No. Point piece dot points. Okay, so now we have our new offset. Our piece offset. Now we have to just do a check here. If p offset dot row equals 0, hits equals true, and break. Otherwise, if the set points contains p offset, that's fine. And we get to here. So if we have hit, that means we need to back it off 1. And then if we have hits, then we also need to go through piece points again. Do this, set points, add the offsets. Now we have a point here. And now set is also true. Is that it? Jet index zone. Okay. We also need highest. Highest also gets updated to be if p offset is greater than highest p offset dot row. I think it's it. I'm trying to think if there's anything else. Sure. Actually, I can just do this. Anything else I can think of? Because in theory, then we just do lap on highest, right? Okay. I'm gonna take in the sample input. Let's run it and let's see how far off we are. The sample input is 3. Okay, we'll get we crashed. Right. Equals jet index plus 1 modulo jet pattern. Nope. Length. Same with piece here. Piece index equals piece index plus 1 modulo pieces dot size. Huh. Alright, let's see what we're getting here. We're stuck in here. Where's our offset? Our offset's way too low. Somehow our offset went beyond. Oh. Somehow our Oh, highest, +2. Or no, +3, I think, right? Yeah, that ain't right. So 0, 1, 2, 3. I feel like it should be +4. I didn't change anything. Okay. All right, where's our first hit? I guess let's do this. Our first hit. Fall. So our first hit is at 3. Row 0, column 3. That is right. But I do row 1. That's whatever. Yeah, it's whatever. Next one's at row 2, column 1. That's not right, though. I'm gonna do an int start y. Trying to get all this debug information I can. So technically this is gonna start 3, 0, 1, 2, 3, yeah. Well, I think it should be starting at 4. That's 0, 1, 2. Wait, where's it starting at? 0, 1, 2. No, this is right. But I don't count this. So it's 1, 2, 3, 4. Right. Okay. And it hit row 0, column 2. Which is right. Column 2 is right because it's column 0, 1, 2. So that is right. And that's row 2. That's also saying it's row 2, column 2. Jet index was at 6. Which is not. Oh, it is right because it's the middle one. Right. Is this supposed to be a minus? Yeah, start at 6. That's right. Right. 0 or 1, 2, 3, 4, 5, 6. That's right. Hit is offset is at 2. which is also right. 0, 1, 2. Offset 4, 0. Okay, so it is right. Is this good now? Am I get the right answer? No, let's look at 4, 4. 4, 4, 8. Okay, so highest is, yeah, it can be 1. Highest is, oh. Oh, okay, I can't put anything there. I'm gonna do it twice just so I can put a breakpoint there. So highest is 1, highest is 4. One, 2, 3, 4, 5. Highest is 7. Wait, what? Highest is 7. Where did I place this one at? Row 5. Row 5. Wait. Something's not right. Hold on. That's not right. One, 4, 7. This one isn't right. Something. Did I mess up on the plus? No? Okay, so this one's, so somehow here it gets messed up. So what are our set points? That's right. Two, 3 on 3. Wait, row 4, column 1. Whoa. Whoa, something. Oh. How about offset dot row or dot column? How about we offset it by the column? Huh. Highest is 4. Wait, sorry. Highest is 1. Highest is 3. Oh no. Where was the hit? Where did it hit it at? No. What did I mess up here? Row 2, column 3. No. Okay, wait, I might have fixed one thing, but I might have broken the rest. Row 1, column 2, which is right. Row 2, column 3. Nope. No, that shouldn't be at row 2. Nope, nope, nope. Oh, because I did it here too. Oh, okay, I guess I'm gonna run it all the way. Wait, did you get it right? Oh, I'm close. Okay, closer. I'm getting closer. Row 3, column 2, that's right. Row 4, column 1. That seems more right. Wait, which was this? Highest is 6. Row 4. That should be a column 0, not 1. They already add these all to set points by this point. Yeah. So there's all those. Those. Row 4, column 1. Yeah, it's already in there. It's in there twice now. Row 4, column 3. So somehow our hit didn't get right, isn't registering correctly. Or it somehow registered. Well, if it should have registered and then backed off of it, shouldn't it? Why did it not? Because any of the points in the piece hits. We get a hit, we break, we go into here. Offset backs it up 1. Huh. Oh, this is why you have to do them individually. I see. Okay. That's probably why I have to do it individually. So it gets pushed and then falls. Okay. So okay, so this needs to get bumped out of here. So what happens is I see. Okay. Hold on. So yeah, first it gets pushed, which is this. So do that, run the checks. So I mean, I should probably put this into a method. Public boolean check piece. Sure. Point offset. Return true. Return true. Return false. Okay, so we're going to go ahead and move it. Hit equals check piece, offset, set points. If it's not hit, we can take this and bump it down 1. I do this char jet char, because if it is hit, we need to run the reverse of this. But we don't know if it hit. Well, if it hit the wall, it didn't move anywhere. In theory, it shouldn't get moved. So in theory, we should be safe to just run this back no matter what. If it doesn't move, it shouldn't be affected. Okay. So if it's not hit, then we can run this hit check, and then again check if it is hit this time. Just roll it back 1. Then good to hear hit. Really, train? Really? Can we not do that? Hopefully it doesn't do it more. Yeah, what do we get? What do we get? Inching closer to that correct answer. Okay. So still 1, 2 is right. Row 3, column 2 is right. I had to think about that for a second. Row 4. Zero, 1, 2, 3, 4. Hey, that's right. 4, 4, 0, 1, 2, 3, 4. Hey, this is actually working. So what's going wrong then? 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 8, 4. They're all working. Yeah. They're all working. Wait, if it's all working, why is my answer wrong? It can't be this logic, right? Because there's no way a piece can move, or a piece can not move. The jet will blow it. It doesn't move. If it's already valid, it shouldn't hit a piece then. We're at 12, 1, 13, 3. 8, 9, 10, 11, 12, 13. Oh. Oh, wait, what? Hold on. Did I just find the bad spot? 3, so the fourth one. 1, 2, 3, 4. So the fourth one here. Row 8, column 4. 2, 3, 4, 5, 6, 7, 8. So it's that one. And then the next one, 10, 1. Next one, 12, 1. 13, 3. Oh. Oh, wait. 12, 13, 1, 2. Yeah, 3. Sorry. 13, 3. 15, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 15, 4. That should be 14, 4. What point's at 14, 4? There isn't a point at 14, 4. What's our current piece? 0, 0, 1, 0, 2, 0. Okay. So row 15, column 4. But there's no 14, 4. Why did it not? Okay, so wait, what comes before 15, 4? What? Is this one running multiple times? This it's in the wild. What? Why is this running multiple times here? I'm so confused. Why? The jet index is increasing. Oh, it's just not hit. That's why. Okay, it makes more sense now. It's just not hit. Okay, so let's just skip this. 12, 13, 3. So I believe 13, 3 is the last one we want. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yeah, 13, 3. So we need to figure out why the next one because it's hitting the side. I got you. Okay, wait. I see the problem. It's because these are not these aren't okay. These should still run mutually exclusive. Only if they both hit. It's hit and that. Well, okay, maybe not hit and that. Boolean, call it down hit. Oh. Sorry. No, that's wrong. It's because that's wrong. But the down hit matters though. If we hit the down, the down's what matters. Because it just came to the side. Okay, wait. Okay, hold on. I'm doing this wrong. Down hit should be just hit. And this is a side hit. Please. I got the right answer. Yes. If we go to our input, go at the same time. It's just the same thing. Yay! Finally. Within our present simulation, they demanded to know how the telltale would be after. Oh. Oh. You know, this might not, Alright, it took me a while to kind of figure this out. I knew it was a pattern, and I did look at the answers or what other people posted for their solutions for bits, and what people said about the cycle triggered me to look harder at the outputs, or the kind of well, you see it's the person I was looking at for their referencer code. But as I was reading these, what people said about the cycle, it made me want to look more at the outputs of the puzzles, and I ended up printing out basically the finished version of this and kind of scrolling up a bit, and I found that as I scrolled up a bit, the pattern became more easier to see. The cycle became easier to see. So I was originally just checking for the first index and finding the first piece and finding the first piece later on. That's not right. I should be checking if any cycle happens. It doesn't matter where. That's what this does. This hit data just kind of stores information about the piece index, the jet index, and the offset and the column, as well as current height. That's used for later. And if these three things are found again, then we know we found a cycle, which is what this does here. And now that we have found a cycle, what we can do is alrighty, well, it's been like 2.5 hours I've been going at this. I got part 1. I'm like close-ish on part 2. I sort of understand. I get the pattern and I know what I'm doing. It's just getting the pattern to work. I don't know. Maybe I'm just getting tired and I'm just kind of losing it. But I got part 1, but unfortunately my now solution is kind of mangled again, so I can't really show the code and go over it. But hopefully tomorrow I can come back and get it. But I think I'm gonna call this one here. I'm struggling these last few days. Maybe tomorrow I'll get back on the right track. But at any rate, thank you guys for watching. I'll see you guys tomorrow for day 18. Peace out.